Hey, 8th grade. So our learning target today is I can solve a system of linear equations using a graphing calculator. So we're going to do some things a little bit backwards today in our work, especially because you're working through the video. What we're going to do is we're going to start by doing all the math, all the POIs, show all of our work. And then at the tail end of the lesson, we're going to pull up those graphing calculators. So you should be on page 8. We're going to take all the notes first. So starting by solving a system using a graphing calculator. We're going to get everything set up in the front end, and then we'll do some work on the back end. So in the front end, there's these notes that we will need later on, these 1 through 5 steps. We're going to just move on for now, and we'll come back to that later in the lesson. So what I would like us to do is, first of all, figure out if there is a solution, how many solutions, and kind of practice some of the things we've been working on. We'll pull the graphing calculators out at the end. So we need to solve for y, as we've been doing. So this one's set y equals 2x plus 5. So there's our first equation. We will enter that in the graphing calculator later in the hour. Our second equation is 3x plus y equals 10. Our job is to solve this equation for y. So we're going to subtract 3x, copy, paste. We're going to work left to right. If I haven't used it, drag it down. We get y equals 10 minus 3x. So we're going to stop, chop, chop here. So that's copy, paste there. We have our y alone. I'm going to flip some things around here because of the community property and say, well, that's y equals negative 3x plus 10. And now we're going to take a look at these two equations based on everything that we've just learned. I'm going to erase that just because I want to clean up my board. Again, if I'm going too fast, go ahead and let me, or go ahead and pause that video. Okay, so here's what we got. Do we have 0 solutions, 1 solution, or infinite number of solutions? Remember, 0 solutions means that the lines are parallel. If they're parallel, they have the same slope. 1 solution means that they intersect somewhere. And infinite number of solutions means it's the same line. So I have this situation going on. Our slopes are 2 and negative 3 different slopes. So therefore, they should intersect one time. We should have one solution. So we're going to go ahead, now that we know that, we're going to go ahead and see if we can find the one solution. So I'm going to set the equations equal to each other down here in this space. So we have y1 equals y2. Keeping in mind that y1 is the first equation in red, and y2 is the second equation in blue. Setting them equal, then, we drop the y's and we solve. So we have 2x plus 5 is equal to negative 3x plus 10. Hand method kicks in. We have a variable equation. We have a variable on both sides. We're supposed to solve for the variable x. Smallest variable goes. Smallest variable right now is negative 3x, so I'm going to add 3x, copy, paste. Working left to right then. I have 5x, if I haven't used it, drag it down, equals 10. Hand method kicks in then. So we subtract 5, copy, paste. And we have 5x equals 10 minus 5 on the right-hand side is 5. Our job is to solve for the variable x, get x totally alone. It's not alone right now, so we divide by 5, copy, paste. So we end up with x equals 1. X equals 1. So we know that the x coordinate in our solution is 1. And then we're going to go ahead and find the y coordinate. We can do that one of two ways. We can either plug it into the top equation or the bottom equation. So we plug in a 1 here and solve. So that's 2 times 1 plus 5. Right up here, plugging in a 1 for x. 2 times 1 is 2, plus 5 is 7. So we think the solution is 1, 7. I'm going to confirm that in the bottom equation. I'm going to plug in a 1 for x and double check that that works out. So that's a negative 3 plus 10 is 7. So our solution is 1, 7. We should be able to confirm that when we get those graphing calculators out that the solution is 1, 7. I'm going to wait to sketch the graph of that. I'm going to see what kind of happens as we proceed through the lesson. So in the next example, actually, you know what? Let's fast graph this. Let's go ahead and fast graph this. So we have our first equation. Going back up here, y-intercept is at 5. Each of these are scaled by 2. So we have 2, 4, 6, 8, 10. So our y-intercept of 5 would be up here. I'm actually going to stick with red, I think. Would be right here. There's our y-intercept of 5, and our slope is 2. Our slope is 2, which really is 2 over 1. Rise 2, run 1. Up 2, right 1. Up 2, right 1. Oops. And we should watch that scale there. That scale on the x-axis is also going by 2. So 2, 4, 6, 8, 10. So up 2 over 1 would be halfway. Up 2 over 1 would be halfway. And so on. So we kind of have this sketch of this graph here. This is the equation y equals 2x plus 5. We're going to do the same thing on the other one. So the other one, the y-intercept here is 10. Remember, we're scaled by 2 here, so be careful on that. That slope there is negative 3. Keep in mind that negative 3 really means down 3, right 1. So from there, we're going to go down 3. So we're going to go 10 all the way down to 7, right 1. Down 3 again. So we're at 7. Down all the way to 4, right 1. Kind of gives us a little taste of what it looks like. Not a perfect graph, but gives us an intersection point. We were looking for an intersection of 1, 7. It does look like we have a 1, 7 as our POI. So we've already sketched it. Later in the hour, we're going to grab the graphing calculators and just confirm that the POI is 1, 7. If that was too fast, go ahead and pause that video. Otherwise, we're going to move on. So our next example here, we have these two equations, y plus x equals 10 and y minus x equals 4. They have to be solved both for y for us proceed. So we have y plus 10, y plus x equals 10, y plus x equals 10. So we're going to subtract x, copy, paste. As I start to solve, we have y equals, we have negative x plus 10, solving the equation. We have y equals negative x plus 10. And then the next equation here. Now I'm kind of out of room, so you maybe are too, but I'm going to try to squeeze it in on the bottom down here. So I have y minus x equals 4. Solving this equation, I stop, chop, chop. I'm going to add 1x, copy, paste. So I end up with, in the equation, I'm trying to solve this equation for y. We get y equals 1x plus 4. 1x plus 4. Those are unlike terms, so we cannot combine those. So we get y equals 1x plus 4. So those are our two equations, both solve for y. Wanting to know if there are one solution, two solution, or one solution, no solution. Remember, no solution means they're parallel, same slope. One solution means they intersect somewhere. Infinite means it's the same line. Looking at the slopes are the key in this question. Here's my slope, negative 1 and positive 1. Different slopes, therefore I'm going to have one solution here. I'm going to fast graph those, again, scaled by 2, so be careful on that because you're scaling up by 2s, 2, 4, 6, 8, 2, 4, 6, 8. Kind of hard to graph when it's scaled by 2s. My y-intercept is up there at 10, and my slope is negative 1, which really means negative 1 over 1. Negative 1 over 1, down 1, right 1. So I'm going to come down 1, right 1, down 1, right 1. Just kind of a little sketch there, down 1, right 1. Little taste of what it looks like, not a perfect sketch by any means. And then my other graph there is 1x plus 4 has a y-intercept up at 4. We're going to rise 1, run 1. Rise 1, run 1. And there it is. So we're looking for a POI. So to check that POI over there, we're going to run those two equations equal to each other and see what happens. So as I do that then, we end up having equation 1 in blue equal to equation 2 in green. So equation 1 in blue is negative 1x plus 10 equals equation 2 in green, 1x plus 4. Solving hand method. Remember, smallest variable goes. When you have a variable on both sides, smallest variable goes. We go add 1x, copy, paste. Solving. We have, if I haven't used it, drag it down. And on the right-hand side, I have 2x plus 4. Hand method kicks in. Subtract 4, copy, paste. Hand method, trying to solve for that variable. We get 6 equals. If I haven't used it, drag it down. We're going to divide each side by 2. Divide by 2, copy, paste. So we get 3 equals x. So our 3 is our POI for our x term. We need to go back in here and find it for our y term. So for our y term, we're going to plug a 3 in here. So we have negative 1 times 3 plus 10. Negative 1 times 3 triangle problem there is negative 3. Add 10 is 7. So we get 3, 7. Go ahead and plug it in the bottom just to make sure that it matches up. That's 1 times 3 plus 4. Is that true? That equals 7. Yes. So our POI is 3, 7. On our graph, it should look close. It might not be perfect because we did kind of make some sketch. So it's supposed to be 3, 7. Kind of close enough there. So we're going to say 3, 7 is our POI. We will confirm that when we graph it on the graphing calculators later in the hour. All right, guys. So that is our two kind of classwork questions. So now we're going to get the graphing calculators out. And now I don't have a live one. So what I'm going to have you do at this time is I'm going to have you go to Google. So everybody follow along here. So we're going to be coming back to this screen. I want you to go to Google. And in Google, I would like for you to do a search. Hopefully I can get it to come up here. In Google, I would like you to do a search of that types in, let's type in TI 84. I don't know if you can see that right now on my screen. I'll see if I can move that. So I'd like you to type in TI I don't know why that's not typing here. Trying again here. TI 84 online. Sorry guys. TI 84 online graphing calculator. So that's what I'm looking for. The TI 84 online graphing calculator. Go ahead and search that. TI 84 online graphing calculator. And this is the screen you should have up. I'll go ahead and wait for you to make sure that you get that up on your screen. Okay, so everybody should have that up on your screen. Okay, so once we get there, there's that top link. That's the one I want you to use. It says Online Graphing Calculator, My HRW Classroom. I want you to use that one. Okay, so you get this as your graphing calculator screen. I'd like you to type in the first two equations that we did there. So I would like you to be back on page 8. We're going to do the top equation. So page 8's top equation, the one I'm referring to is this one. We're going to type these two equations in. I'm going to go ahead and highlight them in blue so you get an idea. Or maybe I'll box them in purple. These are the two equations. I know it's kind of a mess on my screen. So this one here in yellow and this one here in yellow. Once we've solved them for y, we cannot put these in our graphing calculator because they're not solved for y. Okay, so then meet me back on that screen. All right, so we're going to use our y1 equation, our very first equation. It is in the form of 2x plus 5. So you're going to type in that box. You need to type in the number 2. And then you need to hit the X button, which is over on the right-hand side in blue button X. It's over on the right-hand side. It's between pi and that slash symbol, 2x. Then you're going to hit the plus sign over on the right-hand side, black plus sign. And it's 2x plus 5 is the equation we're doing. 2x plus 5, so you're going to type in the number 5. So that's our first equation on page 8, middle box, that top equation, y equals 2x plus 5. And then we're going to type in the other equation, but we need to use the y equals form of it. It's that 3x plus y equals 10, that middle box. But we have to use the y equals form of it. So we're going to go ahead and type that one in. So the second equation then is going to be negative 3x. And I'm not totally sure which sign I use for negative. I'm not seeing a negative in there. Huh. I wonder if I have to use this as my negative. I don't think it's going to accept it. I'm a little nervous about that. Let's maybe use the keyboard negative. Nope. Okay, so negative 3. I'm going to try this and see if it works, guys. Negative 3x then. And then we have a sign of plus. And then we have 10. Go ahead and graph those. And then I would like you to, so you have your two equations. I'd like you to click graph. And you can see that those two problems are intersecting. And if we look on our screen and we were to trace it, I don't know that that's going to do what I need it to do. If we were to zoom in on it, we could kind of get a better idea, but I want to just graph it again. Kind of look at to see, does it indeed intersect at what appears to be 1, 7, and it is looking like it's going to intersect at 1, 7. So intersection point. I think if we put intersection, I'm not really sure why it's not doing that. Okay. So going back to equation, so let's go ahead and clear that out. We're going to graph the next equation then. On the equation on the bottom. So now I'm going to go to the equation that we have on the bottom down here. So these two equations that I have in purple, I've rewritten them as y equals. So we're going to type those in. We're going to take a peek at the graph. We should get an intersection of 3, 7. So we're going to look at that. So going back to my graphing calculator, we're going to clear these out. So we'll backspace or clear those out. There's probably a faster way to do that, but I'm not really sure how. And we're going to type in a negative 1. Negative 1, x, variable is x. And then we have a plus sign, and we have 10. So we have negative 1x plus 10. And then on our bottom one, our bottom equation is positive 1x. Because we put those lonely variables, we took care of those lonely variables. Positive 1x plus 4. Okay, and we're going to go ahead and graph those. So let's look at the graph of those. And we're taking a look at, let's zoom out a little bit to see kind of what happens. We're looking for an intersection of 3, 7, and it looks like we do have an intersection of 3, 7. You could look at it on the graph as well, 3, 7 in the table there. And if we click intersection, I wonder if it would show it to us. So if we hit that and that, and we find intersection points, it's showing us it is 3, 7. So if you click the button intersection and you check on the left both of these equations and say find intersection points, it tells you that it is indeed an intersection of 3, 7 there. So we have one possible intersection point of 3, 7. So that's how you're going to proceed through the rest of the hour. So I know that you have quite a bit of graphs left. So on page 9, you have 3 to do. I would like you to, on page 9 and 10, I'd like you to find the POI first and then use your graphing calculator afterwards. So in page 9 and 10 right now, I want you to go through all of those, rewrite them in form of y equals, then find the POI, put the two equations equal to each other, hand method, find it, sketch it. For questions 1, 2, 3, 4, 5, and 6, I need you to find that intersection and graph it. And then I need you to pull out that graphing calculator following that same link that I just went through and confirm that your point of intersection, POI, is the same as the work that you've indicated. Your homework for tonight then is to finish page 11 and 12 on your own. Page 11 and 12, you will not need a graphing calculator. That's just review questions, y equals mx plus b questions. Have a fabulous night, 8th grade.